Okay, cool. So my name is Kat. Before I get started, let me just give a very quick thank you to everyone involved in DevOps Days, and especially DevOps Days Oslo. So I learned yesterday that this is like a totally voluntary, and so it's really, really nice to get these kind of events going. So my name is Kat. I'm representing N26 as a senior software engineer. So I'm actually no longer at the company, but I applied to do these talks before I left, so here I am. I was there for over 3 years, so I watched the company grow from 150 people when I first started to now close to 1,500. I watched it grow from like 150,000 customers to now over 4 million. So it's been like really quite an honor and pleasure to watch the company grow and mature over the years and kind of change its architecture. And today I'm going to be talking about one of the changes that we had to implement in order to enable multi-region CI/CD pipelines with a DevOps mindset in the phase of massive growth. So hopefully some of you know N26. If not, I'll do a very quick intro into the company and into our previous deployment pipeline. Then I'll go into the actual problem statement of launching in the US, where this need for a multi-region pipeline had arisen, I don't know. And then I'll talk about actually how we configure the applications for multiple regions and wrap up with some lessons learned. So N26 was launched in 2013. It was Europe's maybe one of the first online-only consumer retail banks. It really kind of led this push towards this neo-challenger branchless banking experience. You can sign up in 8 minutes. You get a bank account and debit card with shared accounts, credit, savings, invest, a whole bunch of banking features. On top of that, we also have a bunch of modern features that help you manage your financial life. So monthly spending statistics, real-time push notifications, and a lot of seamless security features built in. So you can disable your card from the app. We also have 2FA on outgoing transfers as well. Here is a quick look at our previous deployment pipeline. So what we do, once your code is ready to be merged into master, we will build your artifact, run a series of tests. It'll go through a security report and SonarQube, and then it'll get deployed to development. So we have a dev environment that's open to devs to do whatever they want. Everyone's like an admin there as well. Once it's deployed to dev, we'll make sure that it's healthy. And if that's the case, then it'll go on to staging. Staging is closed and audited mostly for QA for testing. That's actually a banking requirement. And so once it goes on to staging, we check that it's healthy again. And then we run a series of end-to-end tests on it. And if provided that those all pass, we actually will deploy to live automatically. And live is obviously closed, heavily audited, and only accessible for incidents. So we do practice continuous deployment as often as possible. And in order to facilitate that, we obviously need very good end-to-end testing infrastructure as well. So it's 3 environments, yeah? So that's important, so keep that in mind. Everything is deployed on AWS, and previously everything was hosted out of one data center. This was EU Central 1. So it was one logical data center that all of our services were hosted out of and where all the traffic was going. So in 2017, I had actually gone over to the US to kind of like take a look at what a technical integration would look like, what would it look like to actually launch a banking product in the US. And we had a bunch of meetings with lawyers, and it became painfully obvious that it's it's top legal requirement to have a US data center. US user data has to be fully separated from EU user data, and there's no way around that. So this means that we obviously need to deploy a whole new data center for the US. Around the same time, the kind of mission statement of N26 was to go more global. We wanted to build the banking product that the world loves to use. And what does that mean? You know, the founders had a vision of everyone on every continent with a smartphone can have this better banking experience. And so we would have hundreds of data centers in like hundreds of countries, millions of users. It's going to be great. I mean, it's a very exciting vision, one that I'm super, super behind. The one thing that is not as exciting, if you're like also an engineer, is like, okay, there's like a ton of work to do, literally up until the moment where we achieve this fully global product. And so while cloud providers have done a lot of work in extracting out the hardware and like the virtualization part of it, there's still so much work needed to get a fully functioning data center, right? You need like VPC networks, security groups, new resources and roles to manage those resources, log clusters, secrets. I mean, the list goes on and on. This is obviously not exhaustive. So the question ultimately becomes like, how do we achieve deploying a new data center while annoying the fewest people possible? And this is also because N26 was going through a massive growth phase during the time. There was like 10, 15 new developers every couple weeks. Teams were constantly shifting, and it's just not feasible to say, like, okay, everyone stop developing for 6 months. No one can deploy anything. We need to get this data center up and running. And then everyone, like, move it over somehow. So on a more technical level, the question is, like, what are the clear boundaries between application and environment? And I mean, this is quite a common problem in software engineering. This is something that you should probably ask yourself all the time. Like, how can I build clear interfaces that separate concerns and hide complexity, right? And so to answer that question, let's like move from the whole global, let's zoom in from the global viewpoint to right down to the application hierarchy. So 2 things about this application hierarchy. First thing is I never claimed to be an artist. This is like probably the ugliest thing I've ever written. It's like done in Excel, but it really highlights the problem quite well. Second thing is, this is also just something that I kind of made up for the purposes of this presentation. So you can agree with it, you can disagree with it. You can say like there's more layers, there's less layers. But this, I think, is relatively like a baseline. So at the very top, we have the actual code that's executing our business logic, right? So this could be, I mean, N26 is uses a lot of JVM languages. So this could be Kotlin or Java code running over some kind of web framework, so Spring Boot in this case. It could also be Python over Django, JavaScript over Node, whatever you want. Your application runs in some environment. You have multiple applications running in an environment. And then how does this environment get configured? This is what we typically refer to as the infrastructure level layer. So all of your configuration management and machine provisioning that's creating these, configuring the environment, passing in like environment variables into the environment so your application can access them. So when in theory, a new region should really only affect configuration and not code, right? Because it's not a feature, it's just a new region. We're deploying the same kinds of things there. So again, let's make this a little bit more concrete. Let's say you have a user service that manages users and it connects to a database. This is hopefully somewhat familiar to you. How does the user service actually connect to the database? Well, it's through some like connection string, right? And this connection string will always resolve to something different for every single environment because it's always a different database. So there's some kind of dev EU specific connection string. It's different for staging and live. It's different for the US environment as well. So where can we figure out how to make this user service connect to the database? Well, let's start from the very top layer, the code layer. You can try to configure it in the code. So you get your environment and your region variables, and then from there you have like a whole set of switch statements, like if it's dev in EU, then we'll give it the dev EU one. If it's staging in EU, we'll give it the staging one, and so on and so forth for every environment and every region. This is obviously bad. I hope you don't do this. I mean, a lot of you probably do anyway, but it's bad because configuration is completely indistinguishable from code. So it violates the 12-factor app as well. Adding a new region forces the application to change, and not just the configuration of the application, the actual code of the running application. Let's push it down a little bit more into the framework. I think it's relatively intuitive to have a web framework, make environment variables available to code. So this is again how is how you would do it in kind of a Spring way, but you can imagine it's somewhat similar for other frameworks. You have configuration files that are specific to every single environment, right? So we have an EU, dev, staging live. Again, I don't want to like keep going over that. But for every single environment, we have a specific file, and then in there, that's when we put the actual connection string, right? And then in the actual code is much cleaner because we don't have to do the switch statements. All we have to do is just resolve the value that's defined here, and then it's completely transparent to the application. So this is also this is a better solution, definitely, because your configuration is separated from the code. It's still mostly controlled in the application. But problems with it are, if you let n equal number of environments, m number of regions, like the number of application files can get out of hand very, very quickly. Like you can see here, we only have 2 environments and 3 regions. We already have 6 files plus a constant 3 for like default, local, and testing. And so once you add another region, it's like, it becomes very easy to like miss a file or something like that. And also, it requires a redeploy in case that connection string changes, which you can argue that it's not necessarily the application's responsibility to care that the database connection string has changed. So let's just like keep pushing it down the stack because I don't want to deal with it. What if we put it into the infrastructure layer? So we use SaltStack at N26 for the infrastructure as code layer. And again, it can be anything. It can be Chef, Ansible, Puppet, like CloudFormation, whatever you want. But here's where we actually define environment variables, and then they get passed into the application this way. So this is also relatively intuitive. This is probably a lot of ways that a lot of companies do this as well. And also historically, if you needed some kind of database or some kind of infrastructure, you would tell your DBA or your sysadmin, hey, can you give me a database? And they'll say, okay, they'll spin it up and say, it's available at this connection string in this database, at this environment variable. So all the application needs in this case is to like resolve user database URL, which is good. But so now we actually ended up implementing this solution for a while, and so we had basically everything that was service level started committing into the SaltStack repository, and so every single time I used like a team needed a new database, or they were like, oh, my application needs access to a new Lambda function, or like I want to produce to a new stream, or I want to like access the objects in this S3 bucket. Like you need to configure that in some way, right? And so we'd be also committing to the same repository that is managed by the SRE team, and the SRE team has to worry about other things, right? Like actually configuring the entire environment, so like setting up all your Elasticsearch clusters maybe, Nginx configurations. There's a whole bunch of agents that run underneath the service itself, so like if you use Datadog, Consul, PacketBeat for logs, these things sit all underneath the application, right? So you have all these people committing into the SaltStack repository, and basically it became like a huge bottleneck. So instead of mixing configuration with code, now you're actually mixing configuration with infrastructure, or like application with infrastructure. And so any change to an application actually requires a change in the SaltStack repository, and this is managed by the SRE team, right? And when I say, so they can only be done and merged by the SRE team. And when I say N26 was going through like a huge growth phase at the time, somehow this only applies to back-end and like front-end engineers. Somehow SRE and DevOps are just way harder to hire for. So it was like 5 SREs versus 100 engineers, and it became like a huge, huge bottleneck. So, and I'm talking on the order of days to weeks, where there's like, okay, this PR is still outstanding, and we can't finish this feature yet because like the application is not configured yet. So, I mean, that's all the layers there are. So it's like, where do we actually put configuration management? Because no matter where we put it, it seems like it's a little just out of touch. It seems like it's doesn't really belong anywhere. So in order to solve this problem, I don't know if you're familiar with the 12 networking truths. It was an RFC that came out in like 1996 about just 12 fundamental networking truths. It's supposed to be like taken relatively like lightheartedly. So number 6 is it's always easier to move a problem around than it is to actually solve it. So corollary is when in doubt, just add another layer of indirection and it'll solve your problem. And honestly, that's exactly what we did. So here's our old application hierarchy. You can probably guess like where we're going to add this little line here. There's a nice and it's already kind of split up that way. And you would be entirely correct. So we decided to separate the layers of actual configuration management from machine provisioning, which is the actual environment handling. And so, basically, we kept SaltStack for the base machine provisioning. We introduced Terraform for the configuration management, which I'm going to talk about in a little bit, and also Consul for service discovery and runtime key value store. So before we had just SaltStack. So this was what all the things that SaltStack was responsible for, and this was why this was taking so long to get anything merged, because it was responsible for everything underneath the service, and then also all these things that the service cares about too. Once we introduced Terraform, we actually moved a couple of those bullet points over to Terraform, and so now whenever a service needs something like a new resource, a new access, new whatever, this is actually done in Terraform. And the best thing about it is that this part is team-owned. So the team can actually fix this, do it themselves, and they don't have to wait on the SRE team. And the last thing I'm going to introduce, and I'm like going through this at lightning speed, I know, and I apologize for that, but there's a lot of work. There's like a lot of moving parts to this. Around the same time, we were also started to use Consul for service discovery and our key value store. If you're not familiar with Consul, it's basically a dynamic service registry. So whenever you basically register a service with Consul, and Consul will actually kind of manage where the actual location is, and it'll also make sure that it's healthy. And in case it goes down, it will switch out the instances and make sure that the service is still reachable. And then all the pending service has to do is just use that service.consul key. So basically, it's almost like an environment variable, but it's dynamic. It can be updated dynamically, and it's also managed. So we ended up registering the database with Consul, and now that means that the database is reachable at users-database.service.consul. And again, this part was all managed by the team in Terraform. So again, we go back to that huge YAML file issue. This is resolved in this case because all you have to do is just, we go back to one application.yaml, and it's reachable at service users-database.service.consul. So this ended up being the best solution for N26 because it separates configuration from code and also application-specific needs from the infrastructure. And any changes to these configurations don't actually require a redeploy thanks to Consul. But like with every solution, it's not perfect for there's no solution that's perfect for any company at any stage at any time. So some downsides to something like this is it's obviously more complex. There's more tooling setup needed, like you do need to maintain a Consul cluster, and then you need to bring in all these other tools. So it only became necessary when we reached a certain size, and this is probably also true for you. So, I mean, you can integrate this very, very early, but at some point, it could be just like a source of overhead instead of actually reducing complexity. So the result is that the application doesn't actually care about any notion of region or environment. You'll never see anywhere in code, like, if it's US environment, then do this. If it's EU, then do that. The team owns the provisioning also of service-specific resources. And now our deployment pipeline is just a matter of switching region and environment, which is also managed by the SRE team. So it remains relatively the same. And then when it comes to the deployment time, it will deploy to EU and US in parallel. Then it'll deploy to staging in parallel, run the tests, and then deploy to live in parallel. And again, this is invisible and transparent to the application. So lessons learned here is that your infrastructure as code layer is not just one layer that sits beneath applications. Like there are some layers that belong to what you would conventionally call SRE, but there's also some layers that belong to developers and that the teams should own. And to me, this is like the encapsulation of what DevOps culture is. So it's not just fostering communication and like making sure that you know more things. It's actually helpful in making processes more efficient because it separates the interfaces a little bit more cleanly. And yeah, I think that's it. Any questions? Yeah.
You could travel back in time, alter a decision at some early stage. What would you change? What have you done different?
At the early stage? Yeah, so the question was, if you could travel in time, what would you change? Oh, there we go, sorry. Okay, that's more comfortable now at the end of the presentation. So what would you change if you could go back in time? That is a tough question, even though hindsight is 20/20, usually. I think I would have probably tried to bring this in a little bit earlier because when I say like we were bottlenecked by SRE, and I'm not even saying because it's SRE's fault. This also happened for like quite a long time. This is like this wasn't like, okay, 1 week we figured out, okay, there's problems. It took like on the order of months. So I would say that is something that we would probably, probably do. And then we were also kind of introducing Consul and Terraform at the same time, which is like also a lot of complexity. And so sometimes, actually coming back to like the champions theme, this champions talk, we did have like DevOps champions that I would actually enforce that more. I would definitely push that on each of the teams, and that would also help kind of speed up the process as well. Cool. All right, then, thank you very much. And yeah, let's get lunch soon.